Welcome to Marketing Research course MMPM006. We are having session number 21 and the title of this session is Univariate Analysis 2. The topics to be covered are Z-test for a single population proportion, Z-test for comparing two population proportion. The learning outcome of this session are identify assumption needed for applying Z-test, explain steps needed for carrying out Z-test for a single population proportion and two population proportion. Identify the data needed for using Z-test for proportion or proportions, as well as demonstrate the application of Z-test in business decision making. So here we are looking at the outcome at the end of the session, and you should be able to do this at the end of this session. We are coming to now the testing for a single population proportion. Now, what type of situations we have in this case? Now, it could be validating a given claim or testing a given hypothesis. A claim could be a supplier claims that the mean life of his tire is more than 60,000 kilometers. So we need to test the claim whether what the supplier is saying is exactly true or not. So we need data to validate this claim. This is a claim or a hypothesis. Another example could be of hypothesis testing could be a service provider may say our services are 99% reliable. How do we validate this or test this hypothesis? Now, to test this hypothesis, we collect a sample data, and based on the sample data, we try to see whether information contained in the sample data supports the hypothesis or not. Let's take a case of detailed sample example. A politician claims that he is likely to get 55% of the voters. That is his claim. That's what he feels. Now, this is a hypothesis or a claim. Now, to test this, we take a random sample of 1,000 voters, and out of this 520 agree with him. What can be said about his claim? So, based on this sample data, can we accept his claim or reject his claim? That is the problem before us. So, let us now come to the topic of testing of population proportion. This basically involves categorical variables, and there are two possible outcomes for each trial or observation. So, each sampled unit will be observed on two possible outcomes. One could be possesses characteristics of interest, that is, do they have these characteristics or not, or does not possess characteristics of interest. Characteristics of interest could be life is more than, or the life of the tire is more than 60,000 kilometers. Now, fraction or the proportion of the population in the category of the interest is denoted by P. Coming to the application of Z-test for a single population proportion. Now, this is based on large sample test. We will look at the assumptions for the large sample test later on. To test a hypothesis that a population proportion of events of interest in the population is P, which we call as a success rate. To test this, we select a random sample of size n and find the number of times your event of interest happens. Let us denote the number of successes and number of times an event of interest occurs in the sample, x. Then the sample proportion in the category of interest is denoted by P bar. P bar is the number of events of interest in the sample divided by sample size, which is the same as x over n. So, we calculate x from, we get x from the data, and we know the sample size, and we can calculate x over n to get the sample proportion. Now, Z-test for single population proportion can be applied when both NP and 1 minus P are at least 0.5. P bar or X bar can be approximated by binomial distribution with mean and standard deviation P. That is, P bar, which is sample proportion, and X, the number of successes, can be approximated by binomial distribution, or the distribution can be approximated by normal distribution with a mean P bar equal to P bar equal to P, and standard deviation of P bar, which is equal to P into 1 minus P n and square root of this. Mean of X bar is the number of successes, mean of number of successes given by n into P, and the standard deviation number of successes is given by square root of n into P into 1 minus P. Hence, we use Z test for testing the hypothesis about population proportion. Test can be applied using P bar or X bar. So we have two options to apply the Z test. We can use P bar value or we can use X bar, but P bar value involves more computation, so we will prefer to use X. So this Z for large sample, Z stat is given by, in terms of P bar, when we use P bar minus P divided by square root of P into 1 minus P divided by n. This is one option we have. Another option is Z is equal to X minus NP divided by square root of n into P into 1 minus P. So we compute Z under null hypothesis and use Z table to get the critical region. So we are having two options. We will take the second option to test the hypothesis, which is easier to compute. Now, coming to the assumption for using Z test, we said it is used for large sample size. How large a sample should be? That is, what we have is n into P should be greater than or equal to 5, and at the same time n into 1 minus P should also be greater than equal to 5. Or in terms of X should be greater than or equal to 5, and n minus X should also be greater than or equal to 5. And we should have a random sample and the observations are independent. These are the assumptions required for applying the Z test. Now we take an example to see the application of this or how the Z test is applied. A marketing company claims that it receives 8% response from its mailing. To test this claim, a random sample of 500 were surveyed with 25 responses. Test at 1% level of significance whether the claim of 8% response is correct or not. So we have a situation here where the marketing company feels that they get only 8% response for the mailer they send, and we need to test this claim. So to testing the claim, we take a random sample of 500 and we send the mailers, and out of 500 only 25 responses were received. So we need to test the validity of 8% using the sample data. So before we can apply the Z test, let us check whether the assumptions hold for this. Our assumptions bar n into P, which is equal to 500 into 0.08, which is equal to 40, and the second condition is n into 1 minus P, which is equal to 500 into 0.92, which is equal to 460. That means in both the cases the value is more than 5, so the assumption of Z test holds. So we can go ahead with application of the Z test. Now how to apply the Z test, how to do the computation, we will demonstrate here. First we write the null hypothesis and the alternative hypothesis. The null hypothesis, that is H0 is equal to, that is the claim is right. So that means P is equal to 0.08. Alternative hypothesis, the claim is false. So that is P is not equal to 0.08. So this is the hypothesis to be tested at alpha is equal to 5% and sample size is 500 and number of successes which we have got is 25. So X is 25. Now we apply Z test in terms of X, the number of successes. Z test, as I said earlier, is given by X minus NP divided by square root of n into P into 1 minus P. So we compute this quantity and assuming the null hypothesis is true. So when we assume the null hypothesis is true, X we know from the sample is 25, N our sample size is 500, and P value under null hypothesis is equal to 0.08. Similarly, coming to the denominator part, N is 500, P is 0.08, 1 minus P, 1 minus 0.08 and square root of this. So when we compute this value, which is nothing but the difference between 25 is the observed number of successes minus 40, which is the expected number of successes, divided by the standard deviation, which is equal to, we get the value we get is minus 15 divided by the standard deviation, which is 0.066, and the value which comes out to be minus 2.47. So this is the value of the Z. Now this value has to be compared with the value which we get from the, or the cutoff value which we get from the normal tables, depending upon the alpha value, that is the level of significance, type 1 error, probability of type 1 error. So, and from Z table we know that the cutoff values are plus minus 1.96, plus minus 1.96, because it is a both-sided test. Alternative hypothesis is not equal to, so it is a both-sided test. So my critical region starts from 1.96 to infinity on the upper side, and from the lower side it is from minus infinity to minus 1.96, and our computed value is minus 2.47, which falls in the critical region, which is less than minus 1.96. Hence we reject the null hypothesis. So there is, which falls in the critical region, so we reject the null hypothesis. So there is sufficient evidence to reject the company claim of 8% response rate. That means the company claim of getting 8% response is not valid as far as this sample is concerned. So this is here, what we have done is they tested the validity of the marketing research team, which claimed that the response rate to their mailing is 8%, which we do not accept. Now, just to give you idea about the cutoff values of Z for different values of alpha. So we take different values of alpha. One is 5%, and for both sided tests, Z values are plus minus 1.96, and for one sided it is 1.645. If alpha is equal to 10%, then the Z values corresponding to both sided tests will be plus minus 1.645, and for one sided test it is 1.285. Now if we take alpha is equal to 5%, the cutoff values are plus minus 2.575 for both sided test, and for one sided test Z values are 2.32. Now depending upon the whether it will be minus and pi, that we have to look at the alternative hypothesis. If the alternative hypothesis is less than type, then it will be negative. If the alternative hypothesis is of greater than type, then the value would be negative. We can also test the hypothesis using p-value. So we can calculate the p-value and compare with alpha, which is our 5%. So for a two-tail test, p-value is always two-tail. So since our Z was minus 2.47, so we calculate the p-value. That means we calculate the area to the extreme of minus 2.47. So that is from minus infinity to minus 2.47 on the lower side, and similarly in the upper tail from 2.47 to infinity. So we calculate the total area. So we can get from the tables. So we find that p-value is sum of the area in the lower tail as well as the upper tail, which is equal to 0.008 in one tail. So we double it, and the value which we get is 0.0136. So our p-value in this case is 0.0136, which is less than 5%. Hence we reject the null hypothesis. So when p-value is less than alpha, we reject the null hypothesis. So it is the same conclusion which we have made earlier. One is based upon critical region, another is based upon the p-value. P-values are more applicable for the software packages. Now, having covered the single population case, now we move to Z-test for two population proportion. So here we will use Z-test for comparing two population proportions. Now, let us take a case first to understand how the Z-test can be applied in case of two population. A new soft drink is tested in two cities. So we have two cities, same product is being tested in two cities, city 1 and city 2. So we have two population 1 in city 1, population 2 in city 2, and we are interested in comparing whether the percentage of people liking the soft drink in both the city is same or not. Now the framework which we are using is population 1, that may be city 1 in this case, with population proportion P1. And we take a sample of size N1, and number of people who like the soft drink, or the number of success in this case, is X1. Similarly, we look at the population 2, where the success rate is P2, and the sample size taken is N2, and the number of success, the number of people who like the soft drink, is X2. So we have two samples, one sample from each population, and sample sizes are N1, and for the second population the sample size is N2, and from the once we get these samples, we give the soft drinks and they test the soft drinks, and based on this they say whether they like it or not. So this here is a question of comparing two population proportion, that is P1 and P2. So the same Z test which we have applied can be extended to two sample test, but only thing is the value of Z will change. Now here is a such example which we are going to work out in details with data given. So a random sample of 200 women and 210 men coffee drinkers were questioned. The result was 72 of the women and 58 of the men indicated a preference of decaffeinated coffee. Do these data establish at 5% level of significance that the proportion of the women coffee drinkers who prefer decaffeinated coffee will differ from the corresponding proportion of the men? So we have two population, one is the male coffee drinkers, another is the female coffee drinkers, and we have taken sample from each population, and we have the interest lies in whether they show any preference for the decaffeinated coffee or not. So for the first population, that is the women population coffee drinkers, N1, the sample size is 220 and the number of sexes is 72, which we have observed. And for the second population, the sample size N2, which is 210 for the men coffee drinkers, and the number of sexes is X2, which is equal to 58. That means out of 210 men, 58 have indicated preference for decaffeinated coffee. So the question of interest is the decaffeinated coffee equally preferred in both the populations or not? So here we have a problem of testing the hypothesis, where the null hypothesis, there is no difference between the two populations, that is P1 is equal to P2, and we have to compare this against the null alternative hypothesis of P1 not equal to P2. So here we have a problem of comparing two populations, null hypothesis P1 equal to P2 against the alternative hypothesis P1 not equal to P2. P1 not equal to P2 means the population proportions or preferring they are different in both the cities. Now we use the sample data to test this claim, and we will be using Z test to compute this. Now how do we apply the Z test? Let us look at here. So again we look at the null hypothesis P1 is equal to P2 against the alternative hypothesis P1 not equal to P, and we take alpha is equal to 5%. First we calculate the sample proportion, that means proportion of the individual in the sample 1 or in the population 1 who like the decaffeinated coffee. So it will be X1 over N1. Similarly, same thing for the sample 2, that is the proportion, sample proportion for the population 2, that is P2 bar, which is equal to X2 divided by N2. And then we also calculate P bar, that is proportion of the people who like the decaffeinated coffee under the null hypothesis. Under the null hypothesis, we have P1 equal to P2. That means both the populations are same. So P bar is an estimate of the proportion of the individuals in both the population who like the decaffeinated coffee. So it is X1 plus X2 divided by N1 plus N2. That means we are not considering two samples, but we are considering one sample of size N1 plus N2 and with the number of sexes X1 plus X2. Now in this case the Z test to be applied is P1 bar minus P2 bar minus P1 minus P2 divided by the standard deviation of P1 bar minus P2, which is equal to P bar into 1 minus P bar into 1 over N1 plus 1 over N2. Now we compute the Z value under the null hypothesis. Under the null hypothesis means assuming the null hypothesis is true. Now this computation has to be done. P1 bar we have already calculated, P2 bar we have already calculated, P bar we have already calculated, N1 we know, N2 we know, so we plug in the values to get the value of Z. So in our case, P1 bar is equal to 72 divided by 220, which is equal to 0.3273. Similarly, we calculate P2 bar for the second population, that is X2 bar divided by N2, which is equal to 58 divided by 210, which is equal to 0.2762. And we also calculate P bar under null hypothesis. That means under null hypothesis, we have one sample of size N1 plus N2. So this total sample size is 210 plus 220, and the total number of successes are 72 plus 58, and the ratio which we get is 0.0323. So P bar we have calculated. Now we have to put these values in the Z formula. So P1 bar minus P2 bar minus P1 minus P bar. Now under null hypothesis, difference between P1 and P2 is equal to 0, because P1 is equal to P2, so the difference will be 0, and divide by the square root of 0.023 into 1 minus 0.023 into 1 over 220 plus 1 over 210. So we compute this value. Once we compute this value, we get that Z value is equal to 1.53. Now this is Z value which we have to compare with the tabulated value. So Z value for two population proportion, alpha is equal to 5%. The critical region is 1.96. Again, we use the normal tables, Z tables, to calculate the critical values. So in this case, since the alpha is equal to 5%, so the critical value will be plus minus 1.96, because it is a alternative hypothesis of both sided. So the critical region is from 1.96 to infinity on the right side, and on the lower side it is from minus infinity to 1.96, and our Z value is 1.53, which does not fall in the critical region. So we have no reason to reject the null hypothesis. So we do not reject the null hypothesis at alpha is equal to 5%, and the conclusion is there is no significant difference in the preference of decaffeinated coffee among the women and the men coffee drinkers. So let's look at what we have covered so far. First, we looked at the application of Z test for single population proportion, and then we looked at the application of Z test for comparing two population proportions. Here, in the first case, single population proportion, we take one sample from the population proportion and note the number of successes in the sample, and based on this, and we use the Z test and calculate the value of Z and compare it with the value corresponding to Z value given in the table for a fixed level of significance, that is alpha. If the Z value is more than the critical value, we reject the null hypothesis. Similarly, we did the Z test for two population proportion. We have two population, and each population has different success rate, and we are comparing them under using two different samples. From population 1, we take sample size N1, and from population 2, we take sample size 2. And in each case, we note the number of successes and the number of successes in the first population, and the number of successes in the second population. And based on this, we use the Z test based on using P1 bar, that is sample proportion for the first sample, and P2 bar, sample proportion for the second population, and we also calculate the success rate based under the null hypothesis. The null hypothesis is both the population have the same success rate, and then we compute the Z value, Z values which we have computed is compared with the critical values corresponding to given level of significance, which we have taken as 5%, and if the Z value falls within the critical region, we reject null hypothesis, otherwise we do not reject the null hypothesis. In our case, we had taken two cases. In one case, this was a case of marketing research which claimed that 8% the response they get is 8% to the mailing, and we found out that the null hypothesis was rejected. And in the second case, we looked at the two population of male and female coffee drinkers, and the interest lies in whether they have preference for the decaffeinated coffee. And in both the cases, the sample size were different, and we used Z test and compute the Z value and came to the conclusion that the null hypothesis cannot be rejected because the Z value did not fall in the critical region at alpha is equal to 5%. So our conclusion was there is no significant difference in the preference of the decaffeinated coffee among men and coffee drinkers. So this is the summary of what we have done in this session 21 using Z test. Thank you.